Great, thank you. Yeah, so I am Elise Rumpf, and I work at the USGS Astrogeology Science Center in Flagstaff. And today I'm going to talk about really a series of field guides that we've been working on for the San Francisco Volcanic Field right there in northern Arizona. So this is part of a project called Target, and I'm going to have to look at the acronym because I always forget exactly, which is Terrestrial Analogs for Research and Geologic Exploration Training. So Target is a group that started at Astro a few years ago in response to some community needs that we realized were out there. We realized they're out there through a survey that went out and doing workshops and things that people really wanted a lot more support for terrestrial analogs work. And given the history of astrogeology, we are a good place to provide that support. And so we established Target. And we have a few main focus areas that you can see here. And our main projects kind of overlap within these focus areas. So some of our main goals have been developing training resources and field guides, facilitating research and training trips, so helping folks who come to the area who might need help with their research, and also doing NASA managers trips. So managers who might not have a big geologic background can come to northern Arizona, and folks like Lauren or Jim Skinner show them around and teach them some geology. Also developing science-based decision-making for traverse planning, and then building a data portal for terrestrial analog data so that you can archive your data there and also access other data. And I'll talk a little bit more about that later. And then curation and expansion of analog sample collections. We have a lot of samples at Astro, and so we want to take good care of those and help other people curate their own collections. And so mostly what we're concerned about in this session is training. And the two main things we do for training, as I mentioned, providing training for NASA engineers, managers, astronauts, mission teams. So folks, throughout history have come to northern Arizona. We have a long history. Here's in 1964 testing out, spacesuit and equipment near Sunset Crater. Here they're collecting a soil sample, testing equipment. So we've been doing this for a very long time, since the 60s. And then the other thing that we've been doing more recently is developing standardized multi-purpose field guides for places within northern Arizona. And what I mean by multi-purpose is that we want them to be accessible to a wide audience. So able to be used by grad students, undergrads, managers, mission teams, different folks who might be coming to the area. We want them to be adaptable for folks. And the other thing we mean by multi-purpose is different levels of accessibility. So for each of the guides we make, we have the traditional kind of PDF form where you can print off the guide, take that into the field, and use it as you're walking around to learn about the area you're in. But then for each one, we also create a virtual guide. So we've been using ArcGIS story maps to create virtual guides so that folks who maybe can't travel or maybe have some mobility difficulties and they can't get into the field, they can use our guides to look into to still explore the areas and learn the lessons that we're trying to teach through these field guides. The field guides are also really useful if you're planning a trip to the area. So if you've never been to the area, but you want to do field work, you can review the guide before you come out to learn a little bit about the area before you do your field work. So yeah, as I said, astrogeology is right here in Flagstaff, and we're in Flagstaff because we have this great San Francisco volcanic field around us. This is a distributed volcanic field with 600 vents, and it's really, it's a great place to study because you have all sorts of different kinds of volcanic features and compositions and in different stages of degradation, because the oldest features out here on the west side, some of them are about 6 million years old, and the old San Francisco mountain is about that age too. And then as you progress east, they get younger. So you have, being in a high altitude arid environment, you have really good preservation of those younger, tens of thousand-year-old features, but then you can also have the older, more evolved or more degraded features. So I'm just going to walk through some of the places that we've created field guides for, and some of them will look familiar. So the first one is SP Mountain. It's often called SP Crater. This is up north of Flagstaff. This is a classic cinder cone and lava flow. This is a place probably a lot of us have been. And this is a really good spot. This field guide came out a few years ago, and both as an open file report, you can download as a PDF or as a virtual field or story map. And this is a really good place to learn to interpret volcanic features, both on the ground and in satellite imagery. The next place, and this is coming out very soon as a story map, is the Cinder Lakes Crater Field. And Alicia's going to be talking about this place a little more in her talk. But this is a really cool spot. This was in the 60s. They actually went out to this field that's covered in volcanic ash from Sunset Crater. It's 1,000 years old, and they buried explosives and actually blew up impact craters to create a terrain that is very close to like the moon, so that the astronauts could actually train on a lunar-like environment. And so they were able to, drive the practice rovers around and learn about principles of superposition and how to locate where they are on a map using the impact craters around them. So this field guide can help you learn, about the history of Apollo training in Flagstaff. You can do some of the same activities that they did when they were training, and also learn about crater degradation. Next, we have Red Mountain. So this is a guide that's in development. It should be in review very, very soon. And this is Red Mountain is another kind of typical basaltic cinder cone with a lava flow, except that it has this really cool explosive feature. If you look over, probably maybe where you are, oops, you might not be able to see, but this is the regular eruptive vent, and then over here is another amphitheater. And this happened because during the eruption, groundwater was heated and then created an explosion and blew out this amphitheater. So now you get these really cool geologic features in these hoodoos that have formed over years of weathering and things. In this, it's like cemented scoria that was cemented with calcite. So it's a really cool, unique place. And this field guide kind of focuses on looking at those complex histories that can happen at places that are maybe unexpected. Next, we have Lava River Cave. Brian's laughing. We visited with our fearless survey leaders just a couple of months ago. Here they are. Here's Greg and Christina in Lava River Cave. And so Lava River Cave is a lava tube. It's a little over 600,000 years old. It's about a mile long, and it's nice. It's fairly easily accessible. Some lava tubes are really tricky to get into, but this is a popular hike around Flagstaff. So getting there and getting into the crater and moving through it isn't as difficult as some other places. So we included that in our field guide. And then this field guide, talks about the formation of lava tubes and also the usability of lava tubes on other planets, because, there's ideas that we could, future astronauts could live inside lava tubes. It talks about the habitability of lava tubes, how to make them habitable, and what kind of signs you have to look for once you're in there to know if it's a place where people could live or work. All right, now and Rattlesnake Crater. Okay, here's the last one, the last location. Rattlesnake Crater is another cool volcanic feature in the San Francisco volcanic field. This is a Mar diatreme system. So what that means is that the magma, as it was rising, interacted with groundwater and had was more explosive than some other features. And so this one ended up, you have this really cool tuff ring, and then the tuff is exposed in certain places. So you can see this really interesting deposit there. That's fun to study. So again, this story guide this field guide can teach you about lava water interactions and how to recognize them, again, on the ground and in satellite imagery. Now, to tie this back to one of our other goals within Target that we've talked about.
1 minute warning.
Perfect. Thank you. So to tie this back to our goals, yesterday I presented a poster on the Terrestrial Analogs Data Portal, which is one of the projects about data archiving that we've been working on. And one of the next steps we want to take for the Terrestrial Analogs Data Portal is ingesting more field guides, because we know there are a lot of field guides out there, but they're really hard to find. Some are behind paywalls. Some are probably not published. They're just on professors' shelves that people have taken into the field in the past. And so I'm asking everybody, if you know of field guides out there that have terrestrial analogs applications, let us know. We have an email address here, or just look me up, Elise Rumpf. Or if you have ideas about how to actually find all of these, because it's not an easy search. And if you're interested in building more field guides, also come to me, reach out. We can help with this. And in this ingestion of field guides, we also want to have layers in our data portal about accessibility of sites. So not just how to get there, who are the owners, how do you get permission to be there, and also how mobile do you have to be to get to them? So are they easily hikeable? Do you need a 4-wheel drive vehicle? If someone's in a wheelchair, can they get to this site? So those are the sorts of things we want to add to our data portal in the future. Okay, with that, I'm done.